As a simple example, there is a sequence circuit to automatically supply fuel oil to a settling tank by a fuel oil transfer pump. This sequence circuit controls the fuel oil transfer pump, stopping the pump before the fuel oil in the tank overflows, and resuming pump operation as the level of oil in the tank drops below a preset level. The motor that supplies power to the pump generates a modest amount of heat while operating. However, when the motor has been stopped, its temperature gradually begins to decrease. If the motor's temperature becomes cooler than the ambient temperature, condensation on the casing and coil could result. Condensation inside the motor can result in overcurrent, an event that takes place when insulation resistance between the coils decreases, leading to a short circuit. Reduced insulation resistance between the coil, motor, and the motor frame can also lead to electrical leakage. To prevent such accidents, an electric space heater can be installed in the motor. The space heater is off when the motor is running, and it turns on after the motor has been idle for a preset period of time. In the sequence diagram, the upper half is the main circuit supplying a three-phase electric supply of 440 volts to the motor, and the lower half is the sequence circuit controlling the power supply. Single-phase AC voltage of 110 volts is used in the sequence circuit, but in some cases, AC 440 volts or DC 12 volts is used if the location and conditions require this. The notation method is now being unified under IEC standard, but old JIS or JIS is still used. Now let's take a look at the variety of elements found in the sequence circuit. Switches and relays are classified according to operation. The three types of operation are make contact, break contact, and changeover contact. Make contact is also known as Arbeit contact, which is abbreviated as A contact or Form A. If A contact is not in operation, the circuit remains open and the off state is maintained. The circuit remains closed and the on state is maintained only while A contact is in operation. Because of this, the indication NO, or normally open, will often appear on the A contact terminal. The A contact push button switch closes the circuit when the button is pressed and opens the circuit using spring force when the button is no longer being pressed. Break contact is also known as B contact or Form B. If B contact is not in operation, the circuit remains closed and the on state is maintained. The circuit is closed and the off state is maintained only while B contact is in operation. Because of this, the indication NC, or normally closed, will often appear on the B contact terminal. The B contact push button switch opens the circuit when the button is pressed and closes the circuit using spring force when the button is no longer being pressed. Changeover contact is also known as C contact or Form C. C contact combines the features of A contact and B contact. Prior to operation, A contact is off and B contact is on. When the switch is operated, A contact turns on and simultaneously B contact turns off. The A contactor closes and B contactor opens when the C contact push button switch is pressed, and they return to their original states when the button is no longer being pressed. Shown here is a turnover switch, a C contact with residual function. A control relay is composed of a spring, electromagnetic coil, a free-moving piece of iron, and a relay. When a current is passed in the control relay coil, the coil turns into an electromagnet and attracts the piece of iron. The relay is turned on or off by interlocking with the piece of iron. The electromagnetic power of the coil vanishes when the current passed through the coil drops to zero. Spring force returns the piece of iron to its original position. As you can see, many control relays are of the C contact or Form C type. These are schematic symbols for the control relay. It is expressed as a circle in old JIS and as a rectangle in IEC standard. The number 4 indicates that the particular control relay is for use in the main control circuit. In an actual sequence circuit, the dotted line connecting the coil and relay is often omitted. The main contactor is used to turn on or off heavy load current supplied to the motor or heater. The main contactor's structure is similar to that of the control relay. It turns on when a current is passed through the built-in coil. An auxiliary relay similar to a small control relay is attached to it, and it is interlocked with the operation of the main contactor. In many cases, it is abbreviated as MC in the circuit diagram. The figure 88 is the control device number for the MC. For MCs used on ships, circuit diagrams are just as likely to be rendered in Old GIS as in IEC. The relay may appear to be a capacitor at first glance, but the difference between the relay and the capacitor can be determined easily. Just look for the number 88. The timer relay is a kind of control relay. It can prolong the relay operation, but only for a set period of time. Most timer relays offer a choice of several operation modes. Chief among them are the on-delay mode and off-delay mode. In on-delay mode, the relay begins to operate when a set period of time has elapsed after current is passed through the coil. However, the moment the current passing through the coil becomes zero, the relay returns to its original state. In off-delay mode, the relay begins to operate the moment current starts flowing through the coil. However, when the current becomes zero, the relay returns to its original state once a set period of time has elapsed. The thermal relay is composed of a main circuit terminal with a built-in heater and bimetal and an auxiliary relay. It is used to intercept the circuit when the latter exceeds a certain limit. In the sequence circuit, it is possible to detect overcurrent using this auxiliary relay. The auxiliary relay will not return to its original state even if the excessive current is stopped. Therefore, it must be manually reset once the excessive current error has been resolved and safety has been confirmed. In these circuit diagrams, 51 and THR indicate thermal relays. In many cases, the thermal relay is incorporated in the MCCB and electromagnetic contactor. A variety of sensor switches are used in the sequence circuit. With sensor switches, the relay operates when the temperature, pressure, or water level reaches a preset value. A pressure switch is composed of components that detect pressure and an auxiliary relay. The relay operates when pressure rises above or falls below a set value. It is used for controlling air compressors and air conditioning compressors. With the level switch, the auxiliary relay operates when the water level in the tank rises above or falls below a certain level. There are various methods for detecting water level. In the float-type level switch, for example, the relay is operated by the vertical movement of the float. Since a limit switch is used for the relay, the level switch is often represented using the same symbol as for the limit switch in the diagram. An electrode-type level switch is also used. When multiple electrodes of varied lengths are inserted in the tank, the water level in the tank can be determined by detecting the state of the current passing through each electrode. The upper and lower limits of a tank's water level are indicated by the electrode's locations. The temperature switch relay operates when the temperature rises above a preset value. Thermistor and bimetal are often used in the temperature detection component. In some temperature switches, the relay is operated by a special liquid enclosed in the sensor that expands due to heat. In many cases, the temperature switch is represented in the circuit diagram using the same symbol as for the limit switch. Now let's look at the various devices that can be found in this sequence circuit. The molded case circuit breaker, or MCCB, is often referred to as the non-fuse breaker, NFB, or simply the breaker. The MCCB intercepts the circuit when current exceeding the rated current of the MCCB is passed through the circuit. Capable of raising or lowering AC voltage, the transformer is mainly used in the sequence circuit to reduce voltage. While this transformer is for relatively large electric power, smaller transformers are used in the sequence circuit. The fuse cuts off the electrical circuit when current exceeding a preset value flows through the circuit. The fuse protects various circuits, the main and control circuits, for example, from overcurrent. However, once a fuse is blown, it cannot be reused and must be replaced. Lamps are used to display the operational state of the motor or to display an error. LEDs are used in newer lamps. The merits of an LED include a long useful life, high luminance, and low power consumption. In cases where the sequence circuit is operated by DC and the plus and minus directions of the LED need to be clearly indicated, notations like this are sometimes used. Lamp colors are represented as abbreviations, as shown in this table. Electric motors are classified into single-phase motors operated by single-phase AC voltage and three-phase motors operated by three-phase AC voltage. While the single-phase motor is used for ventilation fans and small cooling fans, almost all motors used on ships are three-phase motors. The schematic symbol for the motor is the same in both old GIS and IEC. Fan marks and pump marks may be indicated along with the motor symbol. In the sequence control circuit, the control circuit is composed of mutually connected devices such as switches, timers, and control relays. Because of this, the circuit wiring becomes complex, making it unsuitable for complex control tasks. On the other hand, when a programmable controller is used, connecting most devices to the programmable controller will suffice, making wiring much simpler. Moreover, in some cases, only the program has to be rewritten, even when the controlling method has been changed, eliminating the need to change the wiring. As such, the programmable controller is the choice for complicated sequence control. The programmable controller is also referred to as a programmable logic controller, PLC, programmable relay, or simply sequencer.